Hi everyone. This lesson is on scientific notation. Scientific notation is used in chemistry, astronomy. Usually it's used when we're dealing with super big numbers or very small numbers. There's a couple examples of numbers that are in scientific notation. The mass of the Earth in tons, 6.65 times 10 to the 21st power. That's the same as this number to the right. Let's see, how many zeros is there? There's 3, 6, 9, 12, 15, 21. 3, 6, 9, 12, 15, 18. 18 zeros. And then 3 more places, that makes 21. 21 places after the first 6. That's where the 21 comes from. 6.65 times 10 to the 21st. Let's see, what number is that? The first period is the ones period, and the thousands, and then the millions, and then billions, trillions, quadrillions, quintillions, sextillion, 6 sextillion, 615 quintillion. Huge numbers, right? Let's forget about that. Anyways, instead of writing a number with all those zeros, we write it in scientific notation. The next one is the mass of a hydrogen atom, 1.7 times 10 to the negative 24. And that's equal to the number on the right. Look at all those zeros. So you could see why we like to use scientific notation for these super huge numbers or super small numbers. All right, so how is a number written in scientific notation? Well, it's written as M, capital M, times 10 to the n, where n, small n, is an integer. That means a number like -5 or 21 or -24. And capital M is greater than or equal to 1 and less than 10. So it could be equal to 1, but it can't be equal to 10. It's got to be less than 10, like 9.8 or 9.9. But it could be equal to 1 or 1.3, but it's got to be less than 10, so it can't be bigger than 10. It can't even be 10. Okay? So let's look at this number. We're going to write this number in decimal notation. Right now, it's in scientific notation. 5.2 times 10 squared. All right, 10 squared. What is 10 squared? Yeah, that's right. It's 100, right? It means 10 times 10. So that's 5.2 times 100. And then 5.2 times 100, to do that, you can use your calculator if you want. Or really what you do is just move your decimal point over 2 places to the right. For every 0, you move the decimal 1 place to the right when you're multiplying. So that number is 520. It's almost the same number, but what do? We move the decimal over 2 places to the right. That's the same number of places as the exponent. The exponent on the 10. The exponent on the 10 is a 2, and that's why you move it 2 places to the right. So that's our shortcut. You just move the decimal point 2 places to the right. Now, what if it's a negative exponent? 10 to the negative 2 is 1 over 10 squared. And 10 squared is 100, so that's 1 over 100. That's 1 100th. 1 100th. That's 0.01 in a decimal. And 7 times 0.01 would be 0.07. So again, the decimal point, well, actually on the 7, there is no decimal point, right? Well, none that we could see. It's actually after the 7. We just don't write it in. That's really 7.0. So we move the decimal point over 2 places to the left. The same number as the exponent. The exponent is 2, but since it's a negative, we move it 2 places to the left. So that's a shortcut. You move the decimal point 2 places to the left. Let's try to make a rule. Converting scientific notation to decimal notation. If the exponent is positive, move the decimal point to the right the same number of places equal to the exponent. If the exponent is negative, move the decimal point to the left the same number of places to the exponent. All right, 2.3 times 10 to the 5th. Sorry, I should have said as the exponent. Equal to, oh, that was right, equal to the exponent. All right, write the following in decimal notation, 2.3 times 10 to the 5th. So it's a positive 5. You're going to move it over 5 places to the right. So you could add as many zeros as you want to the right. So put some zeros, and then that decimal point, we move it over 5 places to the right, and then you put your decimal point there. And then when you write your final answer, make sure you use your commas after every 3 places. So that would be 230,000. 230,000. Okay, in B, 3.1 times 10 to the negative 5, we're going to move the decimal point how many places? 5 places. Which way? To the left. So put some zeros in front of the 3, and then put enough zeros so that you can move it over 5 places to the left. And then put your decimal point. So it's 0.000031. There's 4 zeros in front of the 3. If you wrote just 0.000031, that's okay. Usually we like to put a number in front of the decimal point just to clarify where the decimal point is. So it's 0. It looks better. 0.0. Okay. So just kind of remember this little fact. If it's a positive exponent, you're going to have a large number. 230,000, large number, right? Probably wouldn't mind having that in your bank account. I would be okay with that. If it's a negative exponent, it's a very small number. 0.000031, very small number, negative exponent. So keep that in mind. So if you kind of get confused which way to go, positive exponent, you should get a large number. Negative exponent, you should get a small number. All right, here's a couple more to practice. 7.21 times 10 to the negative 3, negative exponent, small number. Which way should you go? To the left. 0.00721. 2 times 10 to the 7th. Positive exponent? Big number, right? Which way should you go? To the right. When the decimal point isn't visible, it's always at the end of the number. So move it over 7 places to the right. So 20 million. I wouldn't mind having that in my bank account either. I would be okay with that. Okay. Now we're going to go backwards. We're going to convert from decimal notation to scientific notation. So 4,200. All right, what do we want to do first? Let's put the decimal point just so that we can see it. And then we want to move the decimal point to the left to create a number greater than or equal to 1, but less than 10. So we got to move it over. Let's see. Would we want it after the 2 or before the 2? You want it before the 2, right? After the 4. So it becomes 4.2. So that would be 3 places, right? So 4.2. Is that greater than 1 and less than 10? Yes, 4.2 is greater than 1, but less than 10. And how many places do we move it to make it 4.2? 3 places. Is that a large number or is that an extremely small number? It's a large number, so it's going to be a positive 3 for your exponent. So count the number of places you move the decimal point, and that's our answer, 4.2 times 10 to the third. Okay, let's look at the next one. Oh yeah, keep in mind again, positive exponent, large number, negative exponent, small number. How about this next one? Small number, right? So it should be a negative exponent. Okay, so 0.035. Move the decimal point to the right to create a number greater than or equal to 1 but less than 10. What number is that going to be? 35? Not 35, right? That's not less than 10. 0.35? That's less than 1. It's got to be bigger than 1, so 3.5. So we're going to move it right there. So 3.5 is our number. And then count the number of places. How many places would that be to move the decimal point? That's right, 2. And then is it going to be a positive 2 or a negative 2? It's going to be negative. So when you're moving the decimal point to the right here, it's actually negative. And when you move it to the left, it's positive. It gets kind of confusing. That's why I like to always think of positive exponent, large number, negative exponent, small number. All right, here's a couple more examples. $7,600, large number, right? So make your number, it's going to be 7.6. And then how many places are you going to move it? 3 places. And it's a large number, so it'll be a positive 3. 7.6 times 10 to the third. How about the next one? 8.7. How many places? Looks like 3, right? 1, 2, 3. Yep, 8.7. Small number, negative exponent. All right. Write in scientific notation, 0.0007. We need to move the decimal point to the right, and we want our number to be between 1 and 10. So that'll be 7. So you got to move the decimal point from where it is to after the 7. How many places will that be? That's right, 4. So 7 times 10 to the negative 4. Last one. We want to move the decimal point to just after the 7, between the 7 and the 4, so 7.49. And it'll be 4 places that we move it. All right, that's it. I'll see you here for the next one.